Today we're going to be learning about area of triangles and trapezoids. You have been learning about circles and rectangles and parallelograms, but now we're moving on to area of triangles and trapezoids. You will need your formula chart in front of you so that you'll be able to copy down the two formulas that we need. And you will also need a couple of highlighters, some different highlighters, whatever colors of your choice, to highlight your base and your height and the different parts of the triangle and trapezoid. If you need a pause along the way, then pause so that you can stay caught up on my notes. Area of a triangle. A triangle, if I were to draw a triangle, I know a triangle has 3 sides. And I know a rectangle had 4 sides. So if I was going to find the area of triangle formula, then I would think of it in relation to a rectangle. A rectangle was base times height. But a triangle is when you cut it across, you make triangles. It takes 2 triangles to create a rectangle. So if I was going to write my formula, I could use base times height, but there's something special about a triangle formula. It has 1/2 of your base times your height. Area equals 1/2 base times height. When the numbers are all touching like that, that just means you are multiplying them. In 6th grade or elementary, you may have also seen the same formula written like this. Area equals base times height, all divided by 2. That is the same exact concept as taking half. If I were to take half of this rectangle, there's 2 parts of it. So it's the same thing as just dividing it by 2. Dividing it by 2. You can use either way to get the answer. All right, area of a trapezoid. It has a little bit different of a formula, because if I look at a trapezoid, it is a little bit different than a triangle. On a trapezoid, we actually have a top and a bottom, because a triangle goes all the way up to a point. A trapezoid cuts across instead of going to a point. So the trapezoid formula is A equals 1/2 base 1 plus base 2 all times height. All times the height. And if you need more space to write it a little bigger, you can out to the side if that's too small of a box. Now, what do we notice the only difference is between our two formulas? I'm going to use my highlighters to kind of highlight to see what I see that they have in common. And they both have a half. So I still have to cut something in half. They both also have a height. So they both have a height, they both have a half. But then, if I look at these 2 middle things, they also both have a base, but a triangle has 1 base. A trapezoid has 2 bases. 2 bases. If I look at a picture right here of the trapezoid and the triangle together, a trapezoid could sit technically on this or on this if I were to turn it upside down. But a triangle only has 1 bottom. There's nothing on the top of the triangle. So a trapezoid has 2 bases and the triangle only has 1 base. They both have a height, and the height has to go perpendicular to the base. It makes a right angle. And in a minute we're going to look for those. So let's fill in the only difference between these 2 formulas is a triangle. The triangle has 1 base. The triangle has 1 base, and the trapezoid has 2 bases. Trapezoids have 2 bases. And those bases are located on the top and the bottom, in case you want to write that, top and bottom. All right, let's go over what each of these letters stand for, because I see an A, a B, and an H. So let's go over what A stands for. A stands for area. We're trying to find the area. Area is the space inside of your shape. It's what covers the whole shape. When you go buy an area rug to put on your carpet or your floor at home, you're covering a space of your floor. That's area. B stands for base, or the bottom, what it sits on, the base of the shape. H stands for height. How tall, from top to bottom. And it always has to make a right angle. Every shape has to have a base and a height that makes a right angle. The base always has to be perpendicular to the height, always, in any shape that you have. All right, let's see if we can label the parts of some of these triangles and trapezoids. I'm going to label one, and then I'll let y'all label these. So let's start with this. If you notice, these have little tick marks on them. There's a reason they put those there, and same with these little angles having the same little curved arches. That's because this is called an isosceles trapezoid, or sorry, triangle. An isosceles triangle. Anytime I have two sides that are exactly the same, that means also the two bottom angles are the same. The top is different. If they were all three the same, they would be equilateral. I also have another type of triangle right here, and pay attention that it has a 90-degree angle right here. So if I were going to name this, I would name it a right triangle. A right triangle. If I wanted to look at this one, I see that it has an angle 45 and 45. And that means whatever these top obtuse angles are probably going to be the same as well. So they did not draw the tick marks. So if you want to draw the tick marks, you can. But it looks the exact same. If I were to cover up this 8, those lines would shoot up and intersect and make another triangle. So this is actually called an isosceles trapezoid. And the same concept goes for this one as well. If you have a right angle on a triangle, and it's called a right triangle, this is the same exact thing. It has two right angles, and it forms a trapezoid. The only reason that this is a trapezoid is because it has one set of parallel lines, that it has a top and a bottom. It is okay if one side curves and one side doesn't, or if they both curve in. That's what makes it a trapezoid. We have one line parallel to another line, the top and the bottom. This would just be called a right trapezoid. So we're going to highlight the base and height, because I know to find the area of either shape I need a base and I need a height. So let's do the base. That would be the bottom. And then I'm going to do the base of the trapezoid. That would be this one. However, on a trapezoid, remember we said it has two bases, a top and a bottom. Now I'm going to do the height of both of these. The height of the trapezoid is 4. If I look at this one, I don't see a line anywhere. I cannot highlight these slanted sides because when I go to the doctor, they don't tell me to lean backwards or lean forward to measure my height. They tell me to stand straight up and down. And remember, it has to make a right angle like I drew right over here. So on this one, I would have to draw my own height. Even though it's not in there for me, I would draw a little line that represents my height would go from my top all the way straight down to my bottom. On these two shapes, though, you have a straight line that makes a right angle, so you don't have to draw your own line inside. So I'd like you to highlight the base and height where you think they go on here, and go ahead and label them in case you're not using a highlighter. Label as base and height. This one has a height, but it has two bases. It does not matter if you call this one base 1 and this one base 2, or if you want to call this one 1 and this one 2. It really doesn't matter which one, because you are going to be combining your bases according to your formula. So it is okay, it doesn't matter which way you name it. And you're going to label those. So let's try a couple together. Let's do a triangle. So this is a triangle. You might write that just so you remember this one is a triangle example. I want to find the base and the height. My formula states half base times height. Half of your base times your height. Step one to all shapes is we always want a formula written down, whatever formula is gonna that we are trying to calculate. So now let's highlight our base and height so we can plug in our numbers. I have a height of 6 and my base is 4 because it's located at the bottom and going perpendicular is the height, and they make that little right angle. So I would now, step 2, plug in my numbers. Plug in numbers. First step was formula. So I have my formula. Now I need to plug in my numbers. So I don't know the area. And then I write half. My bottom is 4 times my height is 6. So after I have my formula, after I have my numbers plugged, now I can solve it. Now I can do step 3, solve. So I know 4 times 6 is 24. And my goal is to take half of 24. That means I can split it equally into 2 parts. If you need to come to the side and actually do that, you could divide it by 2. If you know how to take half of 24 in your head, then you would know that that would be exactly 12. So the area of this triangle is 12 centimeters squared. 12 centimeters squared. If I was calculating the whole inside area. It does not matter what the 2 side lengths are. That does not matter at all because we don't need the side lengths. We only need the base and the height. In a minute, you're going to do the you do, but let's try a trapezoid problem. So flip the page over, and we're going to try this trapezoid that is kind of on its side. These first 2 were triangles, so let's try a trapezoid. This one is on its side, so let's go ahead and turn our paper, and we're going to do it like this so that you can kind of see it the correct way. So I'm going to write my formula. That's step 1. I know this is a trapezoid because I see a top and a bottom. A top and a bottom. So let's go ahead and write our formula, which would be A equals 1/2 parentheses base 1 plus base 2 times height. The reason they put it in parentheses is because it follows PEMDAS, and they want you to add your bases before doing any multiplication of any parts. So now, step 2, let's highlight everything and plug in our numbers. I'm going to highlight my height, which goes perpendicular to my base. That would be 9. And then my top and bottom bases are 10 and 18. Those little arrows right there on the lines, that's showing you the direction the lines are shooting, and they're both going parallel to one another. They will never crash into each other. That's all that means. All right, let's plug in our numbers. So I have a base 1, I have a base 2, and I have a height. So let's plug them in. Area equals half of my base 1 would be 10, plus my base 2 is 18, all times by 9. So order of operations states do parentheses first, and that would be 28. So my next step is to do half times 28 times 9. If you know how to do half of 28, you could do that first and then times by 9. Or if you want to save the dividing by 2 till the end, then go ahead and multiply 28 times 9 and follow that. So I'm going to come up here and do 28 times 9. 8 times 9 is 72. And then 9 times 2 is 18. Plus 7 is 25. So I would get 252. I'm almost done. This is not 252. It's actually half of that. So I would take half of 252. That'd be 1, and then 2, and then 6. So my total area of the whole thing, since I took half, would be 100 26, and it would be meters squared.